Today what we're going to talk about is we're going to talk about rearranging formulas. Formulas that relate two or more variable symbols, such as a equals LW, d equals RT, and a squared plus b squared equals c squared, arise in different applications of mathematics, science, and other areas of study. These formulas have meaning based on a situation. However, even without an applied setting, formulas can stand on their own as a relationship between variables. You can use the equation solving techniques from earlier lessons to rearrange formulas and solve for a specific variable. So basically what we're going to do today is we're going to look at equations and we're going to pick a variable to solve for, or they're going to tell us to solve for a specific variable. And then what we're going to do is we're going to have to treat all of the other variables like constant terms. So let's look at this first one. Exercise 1. They want us to solve each equation for x, but then they're telling us for part C, remember that a variable symbol like a, b, and c represent a number. So we're going to solve all three of these, we're going to solve for x. So let's do this first one. We have 2x minus 6 is equal to 10. So the first thing that we're going to have to do is we're going to add 6. Add 6. So we get that 2x is equal to 16. Then what we're going to have to do is divide by 2. Divide by 2. So we get that x is equal to 8. Okay? So now let's solve the second one. For b, we have negative 3x minus 3 is equal to negative 12. So what we're going to do is we're just going to add 3. Add 3. So we get negative 3x is equal to negative 12 plus 3 is a negative 9. And then what we're going to have to do is to get what x is, we're going to divide by negative 3. So we get that x is equal to negative 9 divided by negative 3 is a positive 3. Okay? So we're going to use the same strategies that we did for A and B for C now, except for now we're going to solve for x, but keep all of the other variables like constants. So if we're trying to get x by itself, we're going to add b on both sides first. So add b. Okay? And then on this side, so we'll have ax, negative b plus b will cancel, is equal to c plus b. Because we can't combine c and b because we don't know what c is, we don't know what b is. And then what we're going to do to get x is we're going to have to divide both sides by a. So we're going to get x is equal to c plus b divided by a. So we solved that specific equation for x. Okay? So now let's look at this. We're going to look at, it says, for exercise 2. Solve the equation ax minus b is equal to c for b. So now we're going to solve for a specific variable. Here we're going to solve for b. So I'm going to first write the equation. Ax minus b is equal to c. So now what we would want to do is we want to get b by itself. So we want to get this b by itself. We can subtract away ax. Subtract ax. So here we're going to get negative b is equal to c minus a times x. And then what we're going to have to do, if we have negative b and we want positive b, we're going to divide by negative 1. Divide by negative 1. So we get that b is equal to positive c divided by negative 1 is going to be a negative c. Negative ax divided by negative 1 is going to be a positive ax. And now we just solved it for b. Now let's go through and let's solve the equation ax minus b equals c. Now we're going to solve it for a. So if we look at this, we have ax minus b is equal to c. We want to solve for a. So let's put b on the other side. So we're going to add b. So we'll get that ax is equal to C plus B. And then what we're going to have to do is we're going to divide by X. Because we want to get A by itself. So we get A is equal to C plus B divided by X. Okay? So we're basically just solving each equation for a specified variable. We could have the same equation and solve it for each one of the specific variables. Okay? Let's move on to example 1. Let's do an application problem. Here, it says the area of a rectangle is 25 inches squared. So we have a rectangle. A rectangle has length and width. They want us to rearrange this area formula, because we have the formula for area is length times width. We want to rearrange this area formula and solve for L. So let's go through and do that. So if we start with area equals length times width, then we're going to solve for L. So we want to solve for the specific L. To get L by itself, we have L times W. We're going to divide both sides by W. Divide by W. So we're going to get that A over W is equal to L. So we know that our length is our area divided by our width. And now it says if the width is 10 inches, what is the length L? So if we have a width of 10, so first let's write our length is equal to our area divided by our width. In this case, our area is 25 inches squared. Our width here, width is going to be equal to 10, because they tell us right here, our width is 10 inches. And then if we have inches divided by inch squared, we'll just end up with inches. So we have 25 divided by 10, so 25 over 10 inches. Which we can simplify here by dividing by 5 and dividing by 5 in both the numerator and denominator. 25 divided by 5 is 5. 10 divided by 5 is 2. So we'll get 5 over 2 inches. And then the second one says, if the width W is 15 inches, what is the length L? So we're going to have L is equal to A over W. Substitute in for A, 25 inches squared, divided by our width of 15 inches. And if we have inches and inches squared, we're just going to end up with just inches. So we have 25 over 15 inches. But then we could look at this again and we could divide both numerator and denominator by 5. So divide by 5, divide by 5. So we get 25 divided by 5 is 5. 15 divided by 5 is 3. So we get 5 over 3 inches. Okay. Exercise 4. Exercise 4 says solve each problem in 2 ways. First, we want to substitute the given values for the given variable, and then solve for that given variable, and substitute the given values. For A, it says the perimeter formula for a rectangle is P is equal to 2L plus W, where P represents perimeter, L represents length, W represents width. They want us to calculate L when P is equal to 70, so perimeter is equal to 70, the width is equal to 15. So let's do it our first way. Our first way that I'm going to do it is we're going to solve for L first. And then substitute in our values. And then for the second way, we're going to end up just substituting it. So let's look at our first way first. So if we have our formula, perimeter is equal to 2 L plus W. And we want to solve it for L first. So let's solve it for L. If we wanted to solve this for L, we have to distribute this 2. So we have that P is equal to 2 times L plus 2 times W. And then if we wanted to solve for L still, we're going to subtract 2W on both sides. Subtract 2W. So we get P minus 2W is equal to 2 times the length. And now if we have 2 times the length, and we want to have just the length, we're going to divide both sides by 2. Divide by 2. So we get the length is equal to, in this case, we will have P divided by 2. Negative 2W divided by 2 would be a minus W. So our length is going to be perimeter divided by 2 minus the width. So now we want to use this, now that we found L first, we solved for L, we're going to substitute P is equal to 70, W is equal to 15. So we'll have L is equal to, I'm just rewriting this formula, P over 2 minus W. Our P is going to be 70, so we have L is equal to 70 divided by 2 minus 15. So here we'll have 70 divided by 2, which is 35, minus 15. 35 minus 15 would be L is equal to 20. Okay, so that was our first way to solve for L, the length. Another way that we could do it is just by substituting in P is equal to 70 into the formula, W is equal to 15, and then solving for L. So let's go through and do that. So if we look at this, I'm going to first start with my formula. P, perimeter, is equal to 2, length plus width. Okay, and we know that P is equal to 70, so I'll have 70 is equal to 2. Length is what we're trying to find, so I'm just going to leave it as L. And width is 15. Okay, so then again what I'm going to have to do is I'm going to have to distribute. So we have 70 is equal to 2 times L, it's just 2 length, plus 2 times 15 is 30. So then what we're going to have to do is we'll just solve for L. So subtract 30, subtract 30. 70 minus 30 is 40. Is equal to 2 times the length, because positive 30 minus 30 will cancel. And then we're going to divide by 2, and we get L is equal to 20. So in both cases, we got that L is equal to 20. So both ways will work. Alright, let's look at B. B says the area formula for a triangle is A is equal to 1/2 base times height, or B times H, where A represents area, B represents the length of the base, and H represents the height. They want us to calculate B, or the base, when area is 100 and H is 20. So let's look at this. Let's start, we're going to do it our first way, where we're going to solve for B first, and then substitute. For the second one, we're just going to the second way. We're just going to substitute. So this first way, we're going to solve for B first. So we have area is equal to 1/2 base times height. So what we're going to do first, let's get rid of this 1/2. How do we get rid of 1/2? Let's multiply both sides by 2. Okay, so this is part 2 of lesson 19. For part B, it said the area formula. So just to recap, the area formula for a triangle is area equals 1/2 base times height, where A represents area, B represents the length of the base, and H represents the height. They want us to calculate base when area is 100 and height is 20. So basically the first way we're going to look at it, we said we're going to solve for B. So what we're going to do first is just try to get B, this B, by itself. So in order to do that, what we're going to do is we said we're going to multiply both sides by 2, because that will get rid of this 1/2. 1/2 will cancel with 2. So on this side we're going to have 2 times a, or 2a, is equal to base times height. And now if we wanted to get base by itself, all we have to do is just divide by the height. Divide by the height. So we'll have that 2 times the area divided by the height is equal to the base. So now we have that formula. 2 times the area divided by the height is equal to the base. So what we're going to do here is we're going to use this formula. So I'll start with base equals 2 times the area divided by the height. So to do this, I'm just going to substitute in now. Area equals 100, height equals 20. So wherever I see an a, so I'll have base is equal to 2 times 100 divided by our height, which is 20. So our base is going to equal to 2 times 100 divided by 20. 2 times 100 is 200, so I'm going to have the base is equal to 200 divided by 20. So the zeros will cancel. 20 divided by 2 is equal to 10. So our base is going to be equal to 10. Okay. Now let's look at it the second way. So instead of just going through and solving for b first, they just want you to substitute it in. So if we start with our formula, area is equal to 1/2 times the base times the height. What we could do is substitute in for area. A is 100, so I'm substituting in 1/2 times our base is what we're trying to find, and our height we have here is 20. If we look at this, we have 100 is equal to half of 20 is 10, so we're going to have 10 times b. And then we're going to divide by 10, divide by 10. So we get that the base is again equal to 10. So in both ways, we found that the base is equal to 10. So either way would be an acceptable way to find it, by either solving for b first and then substituting, or substituting in first and then solving for b. So either way will work. Okay. So let's go on to the next page. So if we look at exercise 5, now we're just looking at, focus. So now they want us to rearrange each formula and solve for the specified value. And we want to assume that no variable is equal to 0. And the reason that they say that is because we're going to be dividing by variables, and we don't know if the variable is 0. So we're going to assume that each variable is equal to, that no variable is equal to 0. So let's look at this. It says given area A is equal to P times 1 plus RT. And they want us to solve this for P. If we're solving this for P, so they want us to solve for P. If we're solving for P, we're going to have area is equal to, let's start with our original formula, 1 plus RT. And if we want to get P by itself, we could divide by this whole thing in parentheses, 1 plus RT. So if we do it on one side, we have to do it on the other, 1 plus RT. So if we're looking at this, if we want to solve for P, what we could do is, since this will cancel with this, we'll have P is equal to area divided by 1 plus RT. So now we just solved that one for P. Okay, so for the next one, for 2, they wanted us to solve for T. So if we solve this same equation, we're going to solve it for T. So we have area, or A, not area anymore, is equal to P times 1 plus RT. Okay? And if we have this, we're trying to solve for T. So let's solve for this T. In order to do that, we're going to have to distribute this P to both terms. So we get area, or A is equal to P, because P times 1 is P. P times RT is going to be plus PRT. Okay? And then what we're going to do here is we're going to try to get, again, t by itself. So we're going to subtract this p, capital P, subtract capital P. So we get a minus p is equal to p r t. And then what we're going to do here is we're going to look at how can we get t by itself. Well, if we have p times r times t, we could just divide both sides by PR. Divide by PR. So then the PR is going to cancel with the PR. So we'll just get T is equal to A minus P. Minus P divided by PR. Oops. So we'll have T is equal to A minus P divided by PR. And there's T. So now let's look at part B. Part B says given K is equal to 1/2 mv squared. They want us to solve for m first. So I'm going to start by writing the formula. K is equal to 1/2 mv squared. And we want to solve for m. So if we wanted to, let's get rid of this 1/2 first. Let's multiply by 2 on both sides. Multiply by 2. So if we multiply by 2 on both sides, we'll have 2k is equal to, this 1/2 will cancel with that t. We'll just get mv squared. And if we wanted to solve for m, or get m by itself, we could divide by v squared, divide by v squared, and we'll get that m is equal to 2k divided by v squared. So that is m. So now what we want to do is we want to take the same formula and solve for v. So if we wanted to solve for v, I would start with our same formula. K is equal to 1/2 mv squared. And we want to solve for this variable v. If we wanted to solve for this variable v, again, we would first start off by multiplying by 2 to get rid of this 1/2. So I'm going to multiply by 2, multiply by 2. So the 2 will cancel with the 1/2. On the left side, we're going to get 2k is equal to mv squared. Now we want to get this v by itself, so we're going to divide by m. Divide by m. So I'll get 2k divided by m is equal to v squared. Now, if we have v squared and we want to figure out how to get v, what we have to do is on both sides, we're going to take the square root of both sides. Which square root of v squared, I'm just going to move it over here. The square root of v squared is going to be v. And remember, when we take the square root, we have to take the positive and negative case. So it will be positive and negative, the square root of 2k over m. And that's our answer for v. Because v can be both positive, the square root of 2k divided by m, and it could also be negative square root of 2k divided by m. Okay? So now what we're going to do is we're going to look at our last example for today. So we'll look at example 2. Example 2 has equations that contain one variable, and then we could have a related equation. Okay? So we're going to first, they want us to solve this equation ax plus b is equal to d minus cx, and they want us to solve it for x. But if we look at this, we're first looking at both sides of the equation. On both sides of the equation, we have x on both sides. So we have to get x on one side. So let's go through, and I'm going to add cx on both sides. So I'll start with writing my formula, ax plus b is equal to d minus cx. And then on both sides, what I'm going to do is I'm going to add cx on both sides. Add cx. So here I'm going to have, in this case, I'm going to add a plus c. So I'll have a plus c times x is equal, or plus b is equal to, then we have just d, because cx minus cx will cancel. So now what I want to do is I want to get this x by itself. So I'm going to subtract b. subtract b. So we get on this side a plus c x is equal to d minus b. And then if I want to get x by itself, I'm going to divide by whatever this a plus c is. Divide by a plus c. So in this case, I'm going to get that x is equal to d minus b divided by a plus c. Okay. Now let's look at a related equation. Now, instead of just using all letters, we're going to use numbers with x. So let's try to solve this related equation. We have 3x plus 4 is equal to 6 minus 5x. And if we look at this, what we're going to have is we have x's on both sides. So I have to get x to the one side of the equal sign. So on this side, I'm going to add 5x. Add 5x. So I get 5 plus 3 is 8x. Plus 4 is equal to 6. So then what I have to do is I have to go through and solve, get x by itself. So I'm going to subtract 4. Subtract 4. So I'm going to get that 8x is equal to 6 minus 4 is 2. Then what I'm going to do is to get x by itself, I'll divide by 8. Divide by 8. So x is equal to 2 over 8. And if you look at these two, the difference between the equation with one more variable, we did the exact same steps all the way down on both sides. Okay? So let's do the same thing for this one. So this one gets a little complicated. Solve for x. We have ax over b plus cx over d is equal to e. So the first thing that we're going to look at is we have, so I'm just first going to rewrite the problem. Ax over b plus cx over d is equal to e. We want to get rid of these denominators. So to get rid of these denominators, we're going to multiply each term here by a common denominator. So we don't know what b is, we don't know what d is, but to find a common denominator, we could just multiply whatever b is by d. So I'm going to multiply each term by b times d. So I'm multiplying each term by b times d. Okay? And if I do this, I'm going to get the b will cancel with the b. So I'm going to get d times ax. So I'll get d times ax. Plus this d will cancel with this d. So I'll get b times cx is equal to b times d times e. So then what I'm going to do here is I'm adding, and I have x on this side and x in here. So what I want to do, since x and x are common in both, I want to factor it out, or divide out by x. If I divide out by x, it will cancel. I'll get d times a. Whoops. I'll get d times a plus, whoops. So here, let me just start over. I'm factoring out the x. So if I factor out the x, here I'm going to divide out the x to get dA plus, and then if I factor out the x here, it will cancel out, and I'll just get b times c, or just bc, is equal to b d e. And then if I go through this, if I want to solve for x, I'm just going to divide by what's in parentheses, dA plus bc. Divide by dA plus bc. So this will cancel with this. We'll just get x is equal to b times d times e divided by dA plus bc. And that will be my final x. Okay? So now let's look at a related equation. They want us to solve this equation for x. So we have 2x divided by 5 plus x divided by 7 is equal to 3. So the first thing, again, we want to do here is we want to get rid of these fractions. To get rid of the fractions, we're going to multiply by the common denominator here. The common denominator between 7 and 5 is 35. Or we're multiplying 7 times 5 to get 35. And that's exactly what we just did over here. So I'm going to multiply by 35. Multiply each term by 35, or the common denominator. Here we can have the 5 divided by 35 is 7. 7 divided by 35 is 5. And then we'll have 35 times 3. So here I'm going to have 7 times 2x, or I'm going to have 14x. Plus, here I'll have 5 times x, so I'll have 5x, is equal to 35 times 3, which is 105. And then here if I add 14x plus 5x, I'm going to get 19x is equal to 105. And if I want to get x by itself, I'm going to divide by 19, divide by 19. So x is going to equal 105 divided by 19. And again, in both cases, we did the exact same steps all the way down. Okay? Now let's look at the lesson summary really quick. The lesson summary says the properties and reasoning used to solve equations apply regardless of how many variables appear in the equation or formula. Rearranging formulas to solve for a specific variable can be useful when solving applied problems, as we saw in this lesson. Okay? And that is the end of lesson 19.